So we are going to move on today to the cosecant and the secant functions, right? So just like when we were graphing tangent and cotangent, we said, okay, let's see what tangent is made of, sine over cosine. Now we're going to do the same. Cosecant, right? What's cosecant? It's just 1 over sine, is that right? And secant is just 1 over cosine. So the same thing applies here. So suppose, for example, you're talking about the cosecant. It's 1 over sine x. Again, you've got a variable in the denominator. Okay? Again, you're going to have asymptotes when sine of x equals 0. Secant is 1 over cosine. Again, you're going to have asymptotes when cosine of x is equal to 0. Okay? So what these graphs look like, so take a look here at the cosecant graph, right? Look at this. So if this is 0, look at this that I'm going to trace. What graph does that look like to you?
A sine.
That's a sine graph, right? So remember we said cosecant of x is 1 over sine of x? So if you look at that dashed line as the sine of x, cosecant are these right here. Or here, those u's, either right side up or upside down. So the way we draw them is you have asymptotes every time sine hits the x-axis, right? At every one of those points, you have asymptotes. And then in between the asymptotes, you've got your u's like this. So where the sine goes up, cosecant would have a minimum, a low point. Where the sine goes down, cosecant will have a high point, a maximum. Okay? So that's what it's saying here. Cosecant has asymptotes when sine of x is 0. It has minima when sine has maxima, and vice versa. Okay, take a look here. Look at this. Is this something that looks like cosine?
Yeah.
That green one? It is. So remember, secant of x is 1 over cosine of x. So we draw our cosine, okay? And then on top of that, we do the secant just like before. Again, wherever the cosine hits the x-axis are where we have our asymptotes. Okay? So, let's do one of our own. If we were to draw just the secant and the cosecant without the sine and cosine to guide us, that's how it looks, right? So do you see here that the lowest it goes here is 1, and here the highest it goes is -1. So the graph is above 1 or below -1, and here in this region between -1 and 1 is just empty space. Here it's just empty space. There's nothing there. Okay? Same thing here. In that middle section, there is empty space. Okay? All right. So how are we going to graph a secant or a cosecant? We're going to graph the corresponding sine or cosine. Then we draw asymptotes everywhere the sine or cosine crosses the x-axis. And then we draw secant or cosecant. Okay, so let's do this one. What we need to graph here is y equals 2 cosecant 2x. That's what we need to graph. So you ask yourself, cosecant is 1 over what? Sine. So we're going to use the graph of sine x to guide us. So now, we take the identical graph. If it's 2 cosecant 2x, we're going to graph 2 sine 2x.
The period is 1 pi.
The period is pi, right? So the period is 2 pi over 2, which is pi. So now, the first one, I already did it for you, right? So what we would graph is y equals sine 2x. Do you see how this is sine 2x here? Right? Okay, so if you just start from the 0, sine starts at 0, and then it goes maximum 0, minimum 0. Okay? And then what I did is I duplicated it on this side just so we get a little bit more practice with it. Okay? So now what we're going to do is we're going to draw asymptotes everywhere sine of x crosses the x-axis. So I have an asymptote here. I have an asymptote here. I have an asymptote here. And so on and so forth. When you draw it, you're not going to draw as many. You're only going to draw like this portion. I'm just doing more for practice. Okay?
Why only that portion?
Because it's always one cycle that we're drawing.
Should we still draw the other side?
For now. But when you draw, like when we do the rest, we're only going to do one. So now, in order to draw the cosecant, okay, well first let's see where the asymptotes were. I have an asymptote at x equals 0, at x equals pi over 2 and negative pi over 2, and pi and negative pi, right? So plus or minus pi. Okay. So now, how does the cosecant look? Well, here I do a U shape and a U shape.
Do those have to be exact? Or
They have to be
like
exact, pretty much. The important thing is that here at the maximum or minimum, they have to touch
Okay, but like
here.
Do they have to do it?
It has to touch, and here up above and down below, it has to follow the asymptote.
okay. But
Right?
it's a little bit thinner, wider, doesn't matter.
Yeah. Okay?
The main thing is the asymptotes, right?
The main thing is here, yeah, it has to be going up like or down like the asymptotes are, and then it has to touch these points.
That's it?
That's it.
That's easy.
I know. So let's do one from scratch. Let's do one from scratch. Here we're going to graph y equals negative secant 2x.
Cosine.
Correct. That's going to be the cosine.
So the y.
So we're going to graph y equals negative cosine 2x. Okay.
So then the period
So the period is
2 pi over
Pi.
2,
again. So it's
which is pi.
No, I know.
Okay. So now, here's the x-axis.
Are you spacing it out?
I don't think I am. And I'll tell you why. So here's the x-axis. So here's what we're going to do. We're going to do 0 to 2 pi of 2x. Same way, right? So divide by 2. So we're going to go from 0 to x to pi. Okay? So here we have 0, 1, 2, 3, 4 pi. Here's my,
This is an easy one.
yeah. So in the middle, I have pi over 2. First point, pi over 4. 3 pi over 4. Okay. It's negative cosine. That means here I start from minus 1, 0, maximum, 0, minimum. Sounds good? Okay, now.
Oh, because it's cosine, we do the
Mm-hmm.
minimum.
So then
So where do we have our asymptotes?
On 0 and pi.
Is it 0 and pi?
no, pi over 4.
Correct. It's where the graph hits the x-axis.
Oh.
So I'm just used to that.
Mm-hmm.
Yeah.
But now look at what else is going to happen here. There's going to be a little bit of a
So then the dot
there's
is
going to
not-
be a little bit of like what do you call it? Like some drama here because look, I have my U here.
You have to do half of the other U,
Right. See, on the left, I mean on the right side or on the left, I could only do half a U, but that's not cool. So you know what we're going to do? We're just going to extend this a little bit more, a quarter of the way, and get it back up. So now, do I have another asymptote there?
Yeah.
Yes, I do. And so now I could just bring this down. So this is only going to be necessary when you're starting with a cosine. When you start with a sine, that's not going to be necessary.
But then
You already
should
get
we do the other?
No,
half
you don't
on the
have
other
to.
side?
I just want 2 of the u's. That's a complete cycle. So now what happened to our asymptotes? The asymptotes are at x equals pi over 4,
And x
3
equals
pi over 4,
and x equals.
and then,
X is pi.
is that pi?
No, that is not pi. It's over pi.
It's over pi. How much over pi is it?
Pi.
It's
like-
3/4 pi.
It's like pi plus pi over 4. So listen, if you have 2 of them for me, I'm okay with it.
Yeah. Oh,
23.
yes.
No, 2 is good.
And that's it.
That's it. That's it for this. Now I have some practice for you guys. I have some practice for you guys for secant, cosecant, tangent, cotangent.